All right, welcome back to part 2 of this lesson, which is Venn diagrams and how they're related to two-way tables. So I'm sure you guys have all seen Venn diagrams before, whether in math classes or in other classes. In statistics and probability, we'll use this large rectangular area to represent the entire sample space. So this represents all of your possible outcomes. Now, in this case, we're only dealing with 2 events. It's possible to use Venns for more than 2, but after 2, it really becomes a lot easier to use a tree diagram, which we're going to talk about more in next class. So in this case, we're only going to be working with 2. So one of the circles represents one event, and the other circle represents a different event. And these 2 circles, and the fact that they overlap, means that they divide this entire space into 4 distinct areas. So there's this part here, the overlapping part. Then there's 2 sections that are in one circle but not the other. And then there's this outside region which is not in either of the circles. So quick note about terminology. When you see A, of course that represents some event A. And it's represented on a Venn diagram by everything inside of the particular region, which in this case is A. When we're talking about the complement of A, which we write like this, so A with a little superscript C, which stands for complement. The way we usually read this, though, is we just say not A. So this is A, this is not A. And it would be everything in that rectangle that is not in that circle. Excuse the messy coloring job. The intersection of A and B is going to be the things that are in A and in B simultaneously. So the way we read that is A and B. This is the symbol for intersection. It looks like a rainbow, or maybe kind of like a lowercase n. So this is A and B, which again is things that are in both A and B. And the union of A and B is what we were talking about before as OR. So A or B. So the U symbol here, it looks like a U, is for union. So we read this as A or B. And again, that could be things that are in A, things that are in B, or both. So that's how it looks like on the Venn diagram. And again, those symbols are pretty useful to know because they help us use some formulas, which are coming up in a little bit. So let's go ahead and take that male ears pierced example and put the data into a Venn diagram. So remember we started off with 2 variables. One of them was male and not male. So that's our A and not A. And we had ears pierced and ears not pierced. So that's our B and our not B. So I'm going to go ahead and label these 2 circles A and B. So this represents people who are male. Everything outside that is people who are not male. This circle represents people with ears pierced. Everything outside that is people who do not have their ears pierced. So these 4 cells in this table correspond to these 4 regions in a Venn diagram. So if we're talking about people with pierced ears and male, so they have pierced ears and they are male. In symbols, that would look like this. They have pierced ears and they are male. So on the two-way table, that's represented by these people here. There are 19 of them. On the Venn diagram, then, they're going to go right here because they are in A and B, or B and A. It is commutative. It doesn't actually matter which order you put those in. People who have pierced ears and are females. They do have pierced ears and they're not male because that's the way we defined it. So these are people who have their ears pierced and are not male. So these 84 people right here. On our Venn diagram, that would be people who are in circle B, but not in circle A, which is going to be this crescent-shaped region here. There's 84 people in that region. People with no pierced ears and are male. So their ears are not pierced and they are male. On this two-way table, that would be these people right here, those 71 people who do not have their pierced ears and they are male. On the Venn diagram, that would be in this region over here. They are male, but they do not have their ears pierced. And finally, people who do not have pierced ears and are female. So they don't have pierced ears and they are not female. On the two-way table, that's these 4 people right here. And those 4 people are going to be out in this large region of the Venn diagram. Represents people who are not in A and who are not in B. Which seems pretty simple. You do need to know how to use both a Venn diagram and a two-way table. A lot of people find that they prefer one over the other, but you do need to get practice with both. Let's go ahead and review. There's just two really important things you need to remember, and the first is, where do you start? When you're doing Venn diagram problems or creating one or labeling one that already exists, you always start with your intersection. You're going to start with that overlapping part first, and then you're going to work your way out. So you work from the inside out always to find the correct probabilities. If you don't, you're probably going to get some answers wrong. So let's go ahead and see what this looks like. Next page. 100 students in a college in Ohio were surveyed to find out whether they had signed up for a stat class or a history class or both. So I'm going to start by setting up some letters, some symbols for this. I'm going to let S represent students that took stat and H represent students that took history. I have a couple of questions here. How many signed up for statistics but not history? So in symbols, that would be they took stat and they did not take history. How many didn't sign up for either? That would be people who didn't take stat and they didn't take history. So one way of writing that in symbols would be like this. They didn't take stat and they didn't take history. Now we could use this information to make a two-way table, but let's get some Venn diagram practice in. So I'm going to start by drawing a couple of circles and labeling one S and labeling the other one H. I'm going to start, remember, from the inside out. So we know there's 100 students total. 40 students signed up for stat, 30 students signed up for history, and 20 students signed up for both. And that's what I'm going to be looking for, because the 20 that signed up for both are going to go right here. And that's where you always want to start, is from the inside. Now be careful, because you know that 40 students signed up for statistics, but that 40 is not going to go out here. 40 students is how many students total signed up for stat. So there are 40 students in this entire circle. So there are 40 students in this circle. 20 of them are already accounted for here, which means that there are 20 left to be in this region here, because 40 minus 20 is 20. On the two-way table, this is the same as saying, okay, the total for that row is 40, so I'm going to work backward to figure out what number's in that other cell there. Same thing works for history. I know 30 students have signed up for history, so there's a total of 30 students in this circle. 20 of them are here, which means 30 minus 20 is 10, or how many are remaining to be in this region. Now remember, I started off with 100 students to begin with. 20 are here, 20 are here, and 10 are here. That's a total of 50 students that are accounted for. How many are left? Well, 100 minus 50 is 50, so there are still 50 students remaining in this fourth region out here. So if this were a two-way table, the numbers in our table would be 20 and 20 and 10 and 50. The 40 and the 30 and the 100 and a few other numbers would be on our margins. Those would be our totals of our rows and our columns. So let's go ahead and answer this question. How many signed up for statistics but not history? So students that signed up for statistics but not history, that would be this region here, which is going to be 20 students. How many students didn't sign up for either? Of course, would be the people who are in this outside region, and we had 50 students that did not sign up for either class. So to sum up, there is one final example below, and I would like you guys to pause the video now and to do as much as you can. If you get stuck, come on back and I'll go over the answers. So go ahead and pause, and I'll see you in a couple minutes. Hopefully you've had a chance to try this. So, according to the National Center for Health Statistics, in December 2008, 78% of households had a landline, 80% of households had cell phones, and 60% had both. Suppose we randomly selected a household in December 2008. I strongly think that these numbers have changed quite a bit since 2008, but we'll work with the data that we already have. So we start by making a two-way table that displays the sample space. It does not matter whether you put landline or cell phone on the top or on the side, as long as they are both there. It doesn't have to look exactly like the way I did it. So the way I did it is I put landline on the top and I put cell on the side. We have a few numbers here. We know that 78% have a landline, so that's the total who have a landline. That's what would go down here. That's my total for this particular column. 80% had cell phones, that's my total for cell phones, and 60% had both, so cell phones and landlines, my 60% is going to go in this cell right here. Now I know that if I add up everybody, I should get 100%, of course, or 1. So that's going to be my total for the table. Then I can go ahead and fill in the numbers that I don't know, which if you did it correctly, you should have gotten numbers that look like this. Alright, so that's it for two-way tables. I can also make a Venn diagram, and you could do it the same way, the way that we just did for the two-way table, and then work backwards to figure out what these other areas are. Or you could, since you already have a two-way table, you can just use the numbers you've already found. Now again, it doesn't matter like if you use different letters to represent what's going on. I chose to use C and L to represent cell and landline. As long as your numbers are in the right place, that's totally fine. So of course these four numbers are going to be the ones that go here. Again, if you didn't start with the table and you started with just the numbers, you'd want to start from the inside, which is your 60%, and then work out backwards. So 60% here, 78% for this entire circle. You can figure out what must be there. Sorry, that was for 78% for the 80% for the cell and for the landline, and then of course we have our 2% that are neither. So again, these four numbers, same four numbers, just in Venn diagram format. And finally, finding a few probabilities. The household has at least one of the two types of phones. So at least one means they could have a cell, they could have a landline, they could have both. It's just not these people who are here in the 2%. So again, there's a few ways you can think about that. You can find this union here by adding up the three separate areas, or here by adding up these three separate cells. You can use the complement rule and say it's everybody except these 2%, everybody except these 2%. Or you can do, hey, it's the 80 plus the 78 minus the 60. Any way you do it, you should get the same answer, which is 98%. The difference is if you did it using that way, the 80 plus the 78 minus the 60, you didn't actually even need the diagrams you made in part A and B. The probability that they have neither, of course, is going to be either this cell on your table or this region on your Venn diagram, which you should get 2%. And the probability that they have only a cell phone would be people who have a cell phone only, do not have a landline. So that's this area of the Venn diagram here, or this cell of your two-way table here. Either way, you should get that same answer. Now, that last thing there, the parts C and D, this is very common on the AP exam. You're asked to find the probability of at least one something. And the complement of at least one. So at least one means one or more. So it's all of your possible outcomes except for the event that there's none. In this case, it's the probability of at least one of the types of phones. Well, remember one of the ways you could figure that is you could figure out what's the probability they have neither. So they have 0 phones, and then subtract. Because these two events are always going to be complements. So very often, it would be very difficult to figure out the probability of at least one something occurring directly, or at least more work than you want to do, whereas it's actually not that hard to figure out the probability of none of them occurring. So it's easier to do 1 minus the probability of none of those things occur. And this actually goes back to the very first example we did on the tree diagram. What's the probability of getting at least one head out of 3 flips of a coin? Well, it's going to be 1 minus the probability of getting no heads. And again, it's going to be very common to see on the AP exam, both on the multiple choice and the free response. So look out for that. A lot of times it's a lot less work to do it this way. And finally, what is the general addition rule? Is it on the formula sheet, which you should have on your guided reading notes already. And it looks kind of crazy when you look at it on the formula sheet or on your guided reading notes if you've already written it down. And it looks like this. What does this actually mean? The probability of A or B is the probability of A plus the probability of B minus the probability of A and B, which is what we've kind of been doing. Because remember, if we just did the probability of A and B, on your table that would be like doing your 80% plus your 78%, and if you did that, you'd double count these. So that subtraction thing on the end just means subtract out the people that got double counted. So in this context, it would be your 78 plus your 80 minus your 60%. On a Venn diagram, the way it looks is just, it's even easier, I think, because your probability of A is this whole circle, probability of B is this whole circle, and if you did A plus B, you'd want to subtract out your intersection, which is the people who got double counted. And that's what that subtraction thing is doing there. You guys should be good at this point to do your homework. So do your jobs, and I will see you next class. Answer any questions you guys have left on homework. See you soon.